on the News Channel 5 network. This is OpenLine.
Good evening, everyone, and welcome to OpenLine. I'm Carrie Sharp. So happy to be with you tonight. We've got a fun topic that I think you'll probably have lots of questions about because it's what everybody's talking about. The eclipse that's happening next Monday afternoon, and this is the place to be to see it. And I've got the man who can answer your questions tonight, Dr. Ron Henderson, a professor at MTSU of Physics and Astronomy.
That's
I want
right.
to make sure I got that right.
Yes.
Thank you for being here.
Hey, it's a pleasure. I'm really glad to be able to talk about the eclipse, and the public interest is just phenomenal.
It is. It's really grown through the roof. People are excited about it. They're scrambling to find glasses at this point, and we're going to talk about the safety aspect as we go on throughout the show. But I want to remind you, this is OpenLine. This is your chance to call and ask those questions that you've been wondering about every time we run a story about this on the news, or you read it in the paper, or you see something about it online. Go ahead and give us a call. The number is right there at the bottom of the screen, 615-737+. We'll get those calls lined up. But in the meantime, I'm going to ask my own questions for you until we get to hear from you. Dr. Henderson, let's just start with the basics. What is a total solar eclipse?
So a total solar eclipse it's nothing really fancy. An eclipse is just when light from an object in space is blocking sunlight from reaching the other.
Okay.
So we can have two renditions. We can have a situation where the Earth blocks light from reaching the moon, and then vice versa, the moon blocking light from reaching the Earth. So what we're experiencing with the total solar eclipse is the moon blocking light from reaching the Earth.
Which means it's going to be dark in the middle of the day.
It really is. And sometimes, so the frequency is not that often, at least here for Middle Tennessee. It's been over 500 years since the last total solar eclipse passed over Middle Tennessee.
Over 500 years. Wow.
But it's okay. If you miss this one, it's only 500 years to the next one.
Oh, is that all? No problem. Okay.
But so this is one of those cases where it's okay to say it's a once-in-a-lifetime event.
It really is. And now I've been hearing different numbers thrown out, and it all depends how you quantify or qualify that. You said passes over Middle Tennessee, first time in more than 500 years. This is the first one, I believe, to pass over the United States in 99 years. Is that right? Or take the coast-to-coast path?
The coast-to-coast path.
Okay.
So back in '79, there was one that the path kind of just looped a little bit around Washington State. So a lot of people could see the partial phase, but the total was just in that very small area. But you're right, for the last coast to coast, we're at about 100 years.
This one is going to pass from Oregon down to South Carolina, and it's a 70-mile swath.
That's exactly right.
Okay.
So the size of the shadow depends on a lot of things, but one of the things is how big the moon is and how big the sun is, and then exactly how things are aligned for that particular eclipse. So sometimes the shadow can be a little wider, sometimes it may be a little bit narrower. And
this really is all location, location, location. You've got to be in the right spot, and even being off, when we say it's a 70-mile swath, being off just a few miles though, you're out of luck.
This is correct. In Murfreesboro, because we're sort of near the edge, at MTSU we have a nice solid minute or so of totality. But people actually in the Murfreesboro city limits can be out of the range.
Oh.
So one of the things I really hope people will do is take the time to look at a map that shows the path of totality so they're not disappointed.
Right.
I don't want anyone to think that they're in the path of totality, and then when 129 comes,
they're like, what's going on? What was the big deal?
Exactly.
Yeah, it's supposed to be the time. It's broad daylight. What are all these people talking about? They're crazy. Show me your ruler thing here. You brought a great demonstration with the ruler of that really depicts how rare this is, what it takes for a total solar eclipse to happen.
So this is one way to look at it. And so in my ruler, I have a ball here which has a 1-inch diameter. And so this is going to represent the Earth.
Okay.
On the other end is a small ball made out of Play-Doh, very fancy, which has a diameter of a 1/4 inch. Okay. So the ratio is 4 diameters of the moon equals 1 diameter of the Earth. But the other piece to the scale is the distance between the Earth and the moon is exactly, or very close to 30 Earths.
Oh wow.
So with a 1-inch Earth, I need 30 inches. I should turn this around because the inch scale is over here. I need about 30 inches between them.
I understand.
And so if you look at this on end and you think, how in the world can you get the proper alignment for one small dot to the next? I think it becomes a little more obvious about the rarity, about how difficult it is for that to take place.
And we're talking about the moon passing in front of the sun, right?
That's right.
To block that sun from the Earth, and that's why we get darkness in the middle of the day.
I have a couple of photos we might be able to look at to kind of
check it out.
So this first photo shows something about lunar phases.
Okay.
And to kind of get ourselves oriented, there's one sun on the left, there's a single Earth on the right. Those other 8 dots, though, are all moons. And so what this shows us is where the moon needs to be in its orbit around the Earth in order to achieve some type of eclipse. And so when the moon is on the right-hand side, and you can see that the lit up part of the moon is facing Earth, that would be a full moon. So that's the right configuration for a lunar eclipse. But for what we're going to experience next Monday, we need the sun on the left and the moon in the path. And that puts it with the dark side of the moon is facing the Earth, and that's what we call a new moon phase. So the configuration is sun, new moon, and then Earth.
And then we have to be in the right spot to experience it.
We need to be in the right spot. I have the next picture here. This is not to scale. I showed you the scale here just a minute ago. So obviously the sun is not large enough or far enough away. But what I wanted to point out here is that there's 2 types of shadows that will fall on the Earth. There's a really wide shadow we call the penumbra, and anyone in that shadow will see partial phases.
Okay.
In this case, the penumbra covers all of North America. So anyone in the United States in the lower 48 is going to get to see partial phases. But that very small intertriangle, that is where the umbra is. That's where totality occurs, and that's what's going to come right over Middle Tennessee in about 6 days.
That's amazing. Now, when we talk about totality, how long are we talking about that we are going to be in the dark?
That depends on where you are located.
Okay.
Because, so imagine that what's really happening in the eclipse is the moon's casting shadow. And you correctly said that the size of that shadow is about 70 miles. So if the 70-mile shadow is coming to you, and you're in the middle, then you're going to go the complete diameter of that shadow, and in this case that corresponds to about 2 minutes and 40 seconds.
Okay.
So if you're a little further south or north of the middle, you'll still go across the shadow, but not the full diameter. So as you get further south and further north, the time of totality decreases.
And I've heard around here it should be about 1.5 minutes. Is that correct?
That's right. In Nashville, it's about 1.5 minutes. If you go further north, you'll reach 2:40. You keep going north, it goes back down again.
Makes sense. We have Mike on the line. Mike, thank you for calling in tonight and starting us off with questions. What is your question tonight?
Well, my question is how dark is it going to get? Is it going to be like a thunderstorm darkness, or is it going to be like the middle of the night darkness?
Great question. What can we expect?
That is a good question, and it's sort of in between. So the darkness, a lot of people will describe as something close to a full moon. And so it will be dark enough that you'll see some stars and you'll see some planets. Jupiter will be out, Mars and Venus as well. So if you're looking at the sky and you have a clear view, you'll see those planets and some stars. The actual darkness, as I said, about full moon, but what's remarkable about it is how fast it happens. So we're used to full moon darkness arriving over several minutes, let's say 30 minutes to an hour. This is a case where it'll be kind of twilighty, and then boom, just really instantly it gets that dark. So it's going to, our eyes are not going to have a lot of time to accommodate. So it will definitely feel like nighttime.
It is going to be incredible. I know that it has an effect on animals. It kind of throws off their daily rhythm.
That's right.
It has an effect on the weather pretty dramatically sometimes.
Right. Oftentimes in the summertime when there's an eclipse, the temperatures may drop as much as 20 degrees because as the partial phases are happening, we're getting a little less sunlight. And then, of course, for the minute or so, we're getting almost no sunlight. So it's going to feel more comfortable during totality.
After a day like today, I'm okay with that.
That's right. Not a bad thing.
Not at all. We have so much to discuss about this eclipse. Again, it's coming up next Monday afternoon. We would love to hear your questions about it and get those answered. We have the next hour to talk about it, so stay right where you are. Go ahead and give us a call during the break, and we'll get you lined up. 615-737+. We're coming right back.